Hey guys, so today is March 30th, and today we are going to be going over more stuff relating to version control. So last time we met here in our programming teaching series, we were going over version control at a high level, giving a conceptual overview of it using an analogy with the accounts ledger for a business as kind of being parallel to how version control works when working on a software project among multiple developers. So today we're going to be going through some practical examples of version control. So we're going to look at an example pull request that I did in one of my repositories and go through the differences between the repository and the pull request and the branch and the commit and the diff in that process so that we just keep all those things straight in our head. And after we spend some time there, we're going to go ahead and try to set up what's called an SSH key pair. So an SSH, secure socket host, I believe is what the acronym stands for. It's a connection protocol between computer systems. So it's a network connection, and you SSH into other computers to basically to gain access to them. So you use it as a way to authenticate yourself. So if you have a remote server, this is what we did when I was in college. We had a remote server that we could run programs on, it was running a form of Linux. It was called Red Hat Linux. And we could SSH into the server from our own computers and then do things on the remote server. So for us specifically, we're going to be using SSH keys to authenticate ourselves with the version control host that we use. And I'll get into an analogy for this, keeping on in our bank analogy with the business ledgers. We'll get into exactly what this means a little bit later today, but these are the things that I have set out as goals for us today here. So first, we're going to spend a little time debugging if we think we have any local issues for you, try to get unstuck if we have any problems. We'll see how long that takes. And after that, here are the things that I'm planning to have us go through. So based on our conceptual introduction to version control, I want us to have an example of a repository, a branch, a pull request, example commits, and example diffs for these commits to see how all of this works. These are kind of the meat and potatoes of version control here. And after going through that, seeing what version control looks like in code, rather than just talking about it as an analogy, then we're going to go about starting to set it up for ourselves. So the first thing that we're going to need to do is we're going to need to figure out a way to get authenticated. So basically for your local computer to tell the bank, hey, this is who I am a valid person. I should be able to see the account ledger. You should let me see it and copy it down, and you should even let me change it. The bank needs to know who you are before it will let you do that, of course, right? And so the process that we're going to go through in an attempt to do this is using Git Bash, which we installed when we installed Git. A tool called OpenSSH, Sourcetree, and GitHub. So Sourcetree is the graphical user interface for the Git version control system that we're using here, and GitHub is the remote host. So we're going to try to set up this form for us to authenticate using SSH keys here. Then we're going to talk about how you can connect a remote version control repository. So that's like the bank ledger, how you can connect it with your local one. That's like the ledger that a business owner carries around, their personal one. So we're going to talk about how you kind of get the handshake working here. And then we're going to talk about the two ways that you can do this. You can either start remote, so build the bank's ledger first, and then clone it down locally. If you remember, cloning means that you copy the bank's ledger into a personal one, right, for the very first time. This is my preferred method. I think it's kind of easier, and you don't have to do anything on the command line. Or you can start with a personal ledger and then, by way of analogy, get it saved at the bank to create a final copy of it. I think this is harder, so this is not the approach that I typically favor. So we'll do an example of this one, and then if you want, you can try this on your own. So that is our plan for today here. We'll see how long all of this takes us, but hopefully we won't have to cut anything here today. So first thing is debugging. Now you had mentioned that you had some errors trying to load a project here with, having like a child file and importing a function into the parent file. So this is the idea of modules and functions, right? So which project were you trying to run when you were having this problem? Can you hear me?
I can hear you.
Okay. So was it this folder here, Python-exercise-1?
Yes.
Okay.
That's the one.
Okay. So if we open VS Code then, which is the text editor that we're using here, VS Code, then we'll see which directory we're in, because for everything to work properly, you need to have your so-called working space in VS Code be the directory that you're working in, right? So we want the workspace here to be Python-exercise-1 as you've created it there. Okay, and that looks like we're in the right place, right? So we have, if you go to File and then you can open folder like this, that is how you would go about opening the folder here to work in, right? Okay, so that's the first initial step. After that, we can go ahead and take a look at the files, make sure that everything looks fine with the imports here. It's being kind of slow. Okay. So here we are importing from child file, is what you've called it. You're going to import a function called make URL. Okay. So then you're going to print the function that you're calling here, passing in a string. So if we go look at the child file here, this contains the call to the Slugify package that we had talked about as an example package. And you are calling the function here on just some input, which is a string. This looks like it ought to work to me. I don't see anything foreign here. So before we do things, we can go ahead and activate our virtual environment, right? The virtual environment scripts. I think it probably automatically gets activated if you run your project here. And then let's see if you have a launch file set up. It looks like you do. So trial Python, we're always going to run this file, trial.py, in the integrated terminal. Okay, that looks fine to me. I don't see anything particularly noteworthy there. What changes did I make? I don't think I made any changes, right?
No, you didn't, but then I hadn't saved it myself.
Ah,
Yeah.
well, if you hadn't saved it, how would it know which file to run then?
I mean, I just did that, but now that you were closing it, it asked whether to save the changes I made.
But the fact that the changes weren't saved means that according to Visual Studio Code, you were only always running the old file.
Okay.
I'm guessing this is probably the root cause of the issues you were having. So this can really get you. By default, if you don't save a file, there's no way for the program to know that the changes have been made. So you can think of this as like a buffer. Visual Studio Code is saving a set of your changes, and it doesn't actually apply them to the file saved on your computer until you press save or Control S, right? And so what we want here is, as you had your configuration here, we might call this trial. Oops, that is not the right word. Trial as the name of our program. And then we always want to run the main file there, trial.py, rather than whatever file we are on. And my guess is that you were probably trying to run the project from within the child file here, right? So you see that dot right there? Mm-hmm. That means that you have unsaved changes in this file. And if we go look at this in the File Explorer over here, well, I guess it's not showing here. Let me, this should help. Let's show, you see this right here, this check, do you see how I got there? Yeah. Up at the top of this thing over here, there's the three dots that open the menu. If you click Open Editors here, this is how I always have this open. Because it lets you see more than the tabs at the top. Once you have a lot of tabs, like if you have like 20, you need the vertical view to be able to really make sense of them. And so you see that dot, again, that dot means that this file is so-called dirty. It has changes that haven't been saved yet. And so we want to go ahead and save this. We want to save it so that we always run the trial.py file. And if you don't save it, then that means that whatever was there before will be what actually ends up getting run. And what was there before was you had the file parameter being injected here, which means that whatever file you were running in, it was going to go ahead and try to run that. Now, I am not 100% sure that that would be the cause of some of the problems you were having, but it seems like a likely hypothesis. So hopefully this will work, right? I don't want to eat my words here. So now we have it set up so that when we run, it should always run the trial.py file here, which is the main file, the one that we want to be executing that's importing the function from the parent. So if we go to the run menu here, using our new launch configuration that we just made there, we should be able to press run. And this should print out, let's try this again, right? And so you see it's going to activate our virtual environment there. And then we're going to get that warning that we've talked about, but it looks like it's working, right?
Yeah. So did you actually do Control S just then?
I did before, right? And so if we go look in the file menu here, see there's no dot, right? That means that we've saved the changes to this file. And you shouldn't feel bad about this. This has gotten me a couple of times. One of my coworkers actually set up you can set up Visual Studio Code to autosave. It's not a bad idea. Or once you have a bit of experience, it just becomes super second nature. In fact, one of my coworkers, I don't know why, I think he does it to troll us. He set up Control S to actually close out of VS Code. And he's like, well, if I have autosave, I could just remap that key binding, right? Because it saves it for me automatically. So why do let me put something else useful there? And so he remapped it to close the editor. The problem with this is that whenever any of us go to pair program on his computer or code or whatever, by muscle memory, we press Control S a bunch of times because that's what we do normally on our computers. And the problem is he remapped Control S to close out VS Code. And so it's happened enough times now that now I'm really paranoid about it. So whenever I go help him, I'm just like, I'm not going to touch the keyboard unless I'm typing, because otherwise I'll just habitually press Control S and I'll close out of it, and then he'll get annoyed. And I'm like, well, it's your fault. You wouldn't have to rebind it like that. But anyway, funny story. Saving your files is important because if you don't save your files, how is VS Code supposed to know what to run? Okay. So, we can go ahead and try running this a couple more times, and we'll see. I'm expecting that it should work consistently here. Okay, so it worked again there. How many times do you think we need to run this before you're convinced?
No, I think it's okay now.
Okay, yeah. So that seems like the likely thing to me. And it looks like everything else is good. You have a virtual environment set up. I'm assuming the packages that we have installed are inside of this virtual environment rather than globally, as we talked about, right? So if we go to the virtual environment here, we should be able to look at the library where the packages are. And yep, you see how the Python Slugify package is here. And so is the text unit decode, which is the dependency. All of that's here inside the virtual environment, right? Which means it's not on the global namespace, it's inside the box, how we want it, right? And then we go look at the requirements.txt file here, and here's your dependencies. This looks right too, which means that you've used the pip package manager to freeze your packages. I think if we do pip install our requirements.txt like that, it will tell us, hey, you actually already have all the dependencies that you're trying to install here, right? So we already have these requirements. It's telling you could upgrade your package manager if you're interested. But all right, so it looks like everything you have set up here looks proper to me. It means you've understood the lessons. If you know why we've done all of these things rather than just arbitrarily following directions, then that hopefully means that you understand how to set up a Python project and why we would want to structure it this way, right? So is there anything else you want to ask questions on before we go ahead and jump into today's stuff? All right, well, we'll go ahead and get started on the stuff today then. So I'll stick in my browser here. I'll hop back on your computer once we start doing SSH key stuff, but that was us just trying to make sure that we're all good on things that we've done before. So this was the debugging bit of today. Now what we're going to do is we're going to go ahead and we're going to look at an example of many of the version control concepts that we've had. So the first thing we're going to do is we're going to look at an example of a repository. Now, this is the largest unit in a version control system. This is equivalent to the ledger of the bank. We've talked before how you have a local repository. That's the one on your computer. And then there is a remote repository. This is how people refer to them. So local repo. A lot of people will abbreviate repository to repo, like REPO. Very, very normal. So local repo, remote repo. Remote repo, conventionally hosted on things like GitHub here or Bitbucket. There's a couple other providers as well, like Azure DevOps. That's a Microsoft product. They all do more or less the same thing. They serve the function as the shared person who has like the ledger that everyone else pushes and pulls from, if you remember what those words mean, right? And so for us, we're going to be using GitHub, probably the most popular one, especially for open source projects. It's actually got acquired by Microsoft. So Microsoft owns GitHub now, but didn't used to. So this is our remote repository here. So this is a repository. The repository contains folders and files, just like a normal file system does. But what the repository really represents is it represents basically a state of the project, right? This is what all of the files contain at this specific point in time, right? And so right now, this repository, you can see over here, there have been 149 separate commits pushed to this repository over its lifetime. I might actually go click this and you can see. So this is the history tree here. Ever since the beginning of time here, we can see all of the things that I've done on this repository, right? So you see these little things here are the branches. So this is the order. You can see sometimes my messages weren't so great, but a lot of the time it says like remove unneeded information from layouts. Layouts are template files for the thing that builds the website. Close to finishing framework and meta pages. In progress. This is a Q&A page on the website. Use HTTPS and links to the iframe so we don't get security warnings. Each one of these things does like one specific thing, right? Now, I wasn't always so great about this. Sometimes I had more of a like do the thing, like miss tweaks, right? If I go look at this commit message here, I guess it isn't so bad. I'm editing some text in places, right? But not quite as focused a commit. But most of the time, you want to have things be very focused so that you have a set of changes that represents kind of one thing quantifiably. Okay, so this is just an example. These are a bunch of commits that have been put against this repository since I opened it a while ago, but you can see that right now, the current state of the repository, this thing right here, see that? 0f, 8f, 96d. This is like the opening part of a hash. And so the full thing over here is this. This is basically, think of this like a fingerprint. This is the Git's name. So you remember a while ago when we were talking about our example of the bank ledger, I said that, John might have commits 1, 2, and 3, and Robert might have commits 4, 5, and 6, and Joe might have commits 7, 8, 9. You remember when I said that?
Yeah.
So this is what Git, the version control software system, actually uses. So rather than numbers, it uses this. It's a globally unique identifier. It's a hash, basically. And remember when we hashed the password a while ago, right? Hexadecimal, very similar, just like this. So this represents a hash that is the name of the commit, if you will. This is what fingerprints it. This is what makes it different from other ones. In this commit here, this was me. I had made a requirements.txt file for my Python application. And when I had it in the root part of the project, my build server that was actually building the website kept saying, oh, hey, I didn't know this was a Python project. I can't find any of these packages because my version of Python's out of date on the build server because I don't actually need it. I'm not actually running my Python application every time I build my website. It's a pre-processor application. I run this on the website before I push to my build server to build the website. So maybe that doesn't mean anything to you, but this is the latest commit, right? This is the state that is currently active in this repository here. So any questions on repository, what the repository represents? when I say I'm looking at this repository here, at this specific commit message, do you know what all of those words mean?
Yes, I do.
Okay. So this was the first thing for us to just look at an example of a repository, right? Lots of things in it. So that's where we're starting here today. So that was a repository. Next, we're going to look at an example of a branch. So I actually only have one branch right now. You see this list here? Well, I have one branch and it's called master. So if you remember, I said that in real world deployed applications, very common to have multiple branches, specifically 3 or 4, dev, test, integration, and prod. Or actually, usually the order would go dev, integration, test, prod, or just dev, test, prod. And so these would be the branches in your development workflow that you push to before your application goes to the final state before the eyes of the customer. Now, for smaller projects, if you don't have a team, if it's just an individual, I mean, it's probably actually considered better practice to still have a development branch and then only merge things into your deployed site or your deployed app once you've tested the changes and you're sure that they're stable and good. It's probably actually still better style, but a lot of people, me included, just have a single branch that we push to. And so that branch here, this is like the bank ledger. This is called master. We talked about this conceptually last time. So right now, this is the only branch. However, you'll see here that I used to have another branch, and that was when I was doing a pull request. By default, many version control systems, at least if you check a certain box in this, once you've completed a pull request, they delete the branch. So it doesn't stick around anymore. And that makes sense, right? If your changes have been integrated into the main ledger, why would you waste paper recording the same thing in 2 places, right? But what it means is that ever since this branch here, ever since this branch came in, it doesn't exist anymore. And so it got deleted, which is why I only have one branch right now. But this was a pull request. And if we go click on this, that's the next thing we'll be talking about here, pull request. This pull request, I was merging this branch, and this branch was called About the Site Content Section. Okay, so I was adding pages to a new content section called About the Site, and I was merging this branch into the master branch. So if you remember in our analogy, we said that branches correspond to the work for a work item or a task, right? And my task here was I was refactoring to use a new content section called About the Site. So many description pages on my site, things about like the content and the content organization and features relating to the content, like the table of contents and things like that. I was moving all of those things to a new category on my website, basically. That was the purpose of this branch. So that was all the work that was done relating to this. Does all of this track with what we talked about yesterday?
Yes.
I'm going to increase my volume here a little. Okay. This was the pull request. And if you remember, we said pull requests happen once you think your branch is ready to be merged, you merge master into your branch locally, and then you open a pull request saying, hey, I want my changes to become finalized and written into stone. I think everything is ready. Now, if you're ever on a team, pull requests will get peer reviewed by other software developers. Now, for me, this is just my project. So as soon as I opened the pull request, I basically merged it. Usually, it's good to have someone look things over to make sure that there aren't mistakes or errors and that everything is doing what it's supposed to be doing, right? So in a team environment, someone else will be looking over your shoulder, and that's a very good thing. So even if you do a good job most of the time, sometimes they catch something that you missed, right? We're all human. We still make mistakes, and you don't want those mistakes to get written into stone, right? So this pull request, again, was for a specific branch. That branch had a specific purpose. The pull request is integrating the branch into the final history, into the master branch, which is the final history, right? And notably, I remember I told you that for single branch projects like this that only have a master branch, pull requests will basically always be against the master branch on the remote repository. Do you need me to say that again? Or did you get that?
Just the last bit.
Okay, so I said for a repository like this, where there's only one branch, so the final history branch is called master, right? For repositories like that, then pull requests will always go up against the master branch on the remote repository, because that is the final ledger that the bank has, right? That's the real record that if you get audited, that's the current state of the project, right? Just think of our analogy, right? If the IRS audits your company, what record are they going to pull? Well, they're going to pull the one at the bank, right? The one at the bank represents your final record, and master represents the total history on that, rather than a branch like this would represent a pending business deal. And the IRS doesn't care about a pending business deal. They care about what has actually happened, right? What is finalized, not what's up in the air. Okay. So any questions before we keep going?
Just that the master is in this case on your own machine, right?
Mm-hmm.
But if it were a remote situation, it would be you would actually be needing to have the code, the branch you worked in merged with the repository or the branch actually outside your computer.
So this is what this repository looks like on my computer. So I do have this repository on my computer. You see right here, if we look at these files right here, and we compare them to the files in the repository here, you'll see that they're actually exactly the same, right? These two things match.
Yes.
So VS Code app archetypes content, you look here, VS Code app archetypes content, right? This is exactly the same thing. And so how this worked was I worked on the branch that you saw in this pull request. I worked on this branch locally. So this was in my ledger, the one that I carried around, my changes for the pending deal, the pending change set. This was my stuff. And then when I decided that I was ready to integrate this into the final history, what I did was locally, so down here, I see on Bible Docs right now, I only have the master branch, but I could actually create a branch here. This is how you create a branch. So I'll do my new branch like this. So I could create a branch, and I haven't created a branch. If I make changes on this branch here, what I can do is I can merge master into the current branch like this. And I'm just showing you what the commands look like. We'll do an actual full example, top to bottom, once we've set everything up for you, and we'll do it on your computer. But this is what the procedure was. So I made some changes on a branch, and then I pulled down master. I got the most recent history from the bank saying, okay, this is the current state. And then I merged that state right here. I merged it into my new branch, the branch that I had been doing new stuff on, and said, okay, now I have all of my merge conflicts resolved. There are no conflicts between me and the final set in stone history. My stuff's ready to go in, is ready to be integrated. And once I was in that state, that's when I opened the pull request. And then what that pull request represented was the total differences between the new work that had been done and what was already there.
Yeah.
And so if we go look, we can look at the files changed here. This is the total diff, right? This has all of the files changed across this entire pull request here. So everything you're seeing right here, this is why we kind of structure things in terms of individual commits. Because if I show you this, you see there were 140 different files changed in this pull request. And if I were to just give this to you, actually in pull request, this one was pretty big. By convention, you kind of want to keep each pull request smaller because it makes it a lot easier to review. Because if I tell you, hey, go look at 140 files, your eyes are just going to glaze over, right? If I tell you, hey, go look at 5 files where I do similar things, that's more manageable, right? Now, the repository I'm showing you right here is actually kind of a special case because it's a website. So some of these pages that you're seeing here, these are actually like this is a markdown page. This is like text content. It's not actually code, right? So a whole bunch of files will change on a text website like this. It's a little bit different than normal coding situations. If you ever open a pull request in a normal development project and your pull request touches 100 files, people are going to tell you, you probably shouldn't do that. That's almost too much. It's going to be too big to review. It's going to be really hard for people to wrap their head around what changes you're making. But nonetheless, this shows you the change set of that pull request against the master branch. It shows you all of the files that were changed in this pull request, everything that went into doing this goal here, refactoring to get a new content category on my website. We're doing okay?
Yeah.
Okay. So you saw example commits. Let's go look at the commits. These are all of the commits in the pull request. So you can see our wider goal here is to add this new content category and move things to it, right? So the first thing that I did was I updated site pages. I added an icon. Let me see more things here. Well, okay. I mean, I added lots of stuff here. Refactor select site pages, add summaries to some of them. This is a good example commit here. So in this commit, what I was doing was I was adding summaries to some of the about the site pages and some of the other pages on our website, right? So this site, this page here was called a brief technical summary of this site's backend. So I actually, in my most current version of my website, decided, you know, I don't need to start with this file. How many people are going to care about the web servers that I'm hosting my site on and why it's so fast and all of that stuff? Most people won't, right? Most people, if they're interested in my Bible teaching website, are going to be interested in the Bible teaching, and they won't care about this. But this was a page where I did write stuff about this. Here's a page where I was talking about the focus of my ministry and stuff. Again, this has changed. All of this stuff's a bit old now, as of today in March 2022. But these were things that I was working on at this point in time, right? So I was talking about the level and how I have application centers or application sections and how we're trying to keep the focus and all of this on the Bible and things like that. So you can see these were all of the things here. These are the diffs for all of these different files that were touched in this individual commit. And this individual commit, in turn, is part of the pull request where we were merging the branch that I did all of this work on into the master branch. Does that all make sense?
Yes.
Okay, so each one of these commits represents something I was doing, a more focused set of operations that I was doing to help implement my wider goal here of adding a content section on the website. Okay, so that's commits, diffs, right? We've seen all of these. Do you have any questions on what I've gone over here? So this is an example in code of all of the concepts that we were talking about last time we met.
Yeah. I don't have any questions.
Okay, now, of course, it will be a little bit different when you start doing it yourself too. It's always easier to kind of nod along when someone else is doing it. And then when someone says, okay, now you do it, then it gets a little bit harder. But we'll do that. We'll do that as soon as we're able to, so that you get some actual practice on your own here. Okay, so that was our example here, going through a real code example of version control stuff, of all the things that we've talked about. The thing that we're going to move into now is this idea of letting our remote repository, so this is a remote repository, of letting our remote repository basically recognize us and allow us to check the ledger, the account summary that we have here, so that we can push to it and pull from it. It needs to know who we are before it will let us do that, especially pushing. Before you can go write things in the company's accounting books, the bank sure better know who you are, right? They're not going to let just anyone write things in there, right? So for that reason, they need to know who you are. So continuing our analogy here, I say when you connect to a remote repository, you need to be authenticated. Would a bank just let anyone see the company ledger and especially modify it? No, right? That's what we just said, right? That's not realistic. That's not how it would work in our analogy situation either. So just as then, you could authenticate with a password each time you want to push or pull. So just how you log into websites with a username and a password, you could do the same thing every time you're trying to modify your remote repository in version control. So for us specifically, we're using Git. So every time you want to use Git to push your changes, you might have to enter a username or password. That's kind of inconvenient, right? I mean, you can do it. It's certainly not that bad, but it's kind of inconvenient. In the real world, fancy business owners might have ID cards that they can scan in an RF signal card reader to get them access to their important company vault quickly. So they go in, they're in a secure place, and they scan their card with the card reader, and it lets them get into the vault. And inside the vault, that's where they store their company ledger, right? At the bank. And so we can actually do something very similar to this idea of your ID card and the card reader. We can do something very similar to that as developers working on a repository. So for us, our quote unquote ID cards are called SSH keys. Again, secure socket host, you don't have to worry about the acronym or really what it all represents. Just know that in our situation, these are very similar to ID cards for people going into secure areas. This represents who you are, it's your identifier. And so our SSH keys are a matched pair of authentication hashes. So remember the big long things we saw over here. This is a hash, right? The SSH key is like this, but long. It represents your fingerprint, your identity, hence authentication. So you can think of our SSH keys that we're going to set up here in the exact same terms as the RF signal card and card reader from our analogy in the business situation. So just as in the physical world analog, the card reader has a set of people whose chips it knows, right? Those are the people who have access to a specific place. Whenever it scans those people's IDs, it'll let them in. But if you're not on that list, if the card reader doesn't know who you are, it will reject you, right? Say, you don't have access to this. So for us specifically today, the very first time, just as in a physical situation, this happened to me. I actually work on an Air Force base. When I work for the Air Force, I have an identification card. To get into certain places, like on base, I have to show my ID, right? They don't let me just drive on. But the very first time I was getting on base, I had to go, they had to, take my fingerprint, and I had to, pass a drug test and all this other stuff to get my ID card the very first time, right? And then it got registered with security people, and they say, okay, we know who you are now, right? That is the sort of step that we need to take right now. We will have to, quote unquote, go to security and get them to register our card with the card reader so that in points in the future hereafter, the card reader will recognize our card and it will let us in. Does the analogy we're using make sense? Does it make sense what we're trying to set up here?
Yes, it does.
Okay. So what we're going to do is we're going to try to use these tools here: Git Bash, OpenSSH, Sourcetree, and GitHub. So we looked at this one and this one and this one last time. We installed Git, and with Git came this shell called Bash. So Git Bash. Sourcetree was the visual front end for Git, the graphical user interface we talked about, and GitHub was what we were just looking at here. This remote repository provider. So the steps that we're going to try to go through here, hopefully this works. It's actually been quite a long time since I've last done this. So I have SSH key set up on my personal computer at home, so I can push to my own Git repository like this. So if I go to my account here, this is me. You can see some of my repositories and so on. If I go see if I can find settings, maybe somewhere. Oops, I guess I'm not signed in. So use my password manager here. So I'm going to sign in to my Git account. Now I can go probably see my settings here. That's profile. I want to go look at my settings, and somewhere here, I think it will probably have SSH and GPG keys. So there is my public key right here. So you see, I have two computers registered on my Git account. These are the equivalent to my ID cards, right? These are my public keys. I have the thing that this thing pairs to. The thing that this thing pairs to is what I have on my, this is my home computer here. This is my work computer. These things I have locally. These are what I scan to get in. So these things are on my Git account or on my GitHub account, and they let me in when I scan, basically. You see, I have these keys here set up. This is where you're going to set it up on GitHub as well. First, though, we need to generate the keys, the things that match each other here. And so to do that, let's come into our Chrome Remote Desktop session here. Oops, we've got Zoomception there. You might want to get off the Zoom window.
I have.
Okay. Okay, cool. So now we're going to open git bash. So, git bash like this. Okay, so now we have a bash shell. Maybe we'll make the text a little bigger like this. And if you see this squiggle here, the tilde, this means we're in your home directory, right? So if I ls right here, so I list everything here, you see where there's a documents folder, a downloads folder, etc. This means we're in your home directory, right? And actually, I'll do the full list here so we get everything, including all the permissions. Some of these things are directories. Let's actually see if we can see, including the hidden stuff. So you have some things here. You have config files here. So you have a VS Code folder that contains your configuration for VS Code, a git config file, and these other configuration files here, so-called dot files. So we're going to add something to one of these. We're going to have an SSH folder that gets generated here. So how do you do this? Well, it actually so happens that a very long time ago, back in 2018, I wrote a blog post about this. Now, my blog is kind of out of date. My website, haven't updated it. I was very terrible as a blogger. I was very inconsistent, but this was back when I was in college, and I was talking about how I was very frustrated because I had to change my password on my school's remote server, and then it basically didn't update for a while because, well, now that I'm in a professional development environment, I'm convinced it was because they didn't set their server up very well. But in any case, I was annoyed by this. And at that point thereafter, I swore to myself that I would not use passwords anymore. I would use SSH keys. So I had to go figure out how to do it. And so we'll use something called OpenSSH here to generate our public key. For now, you don't have to worry about it too much. OpenSSH is maintained by these people who make an operating system called OpenBSD. And it's a very widely used SSH utility. And what we're going to do with it is we're going to go ahead and make an SSH key. So we're going to go ahead and clear our screen here. And so this was my blog post. It links to something else. Here's the more official site. This is some university explaining how to do it. So we're going to use this command here on the command line to go ahead and build an SSH key. And we're going to specify the type is going to be RSA. That's the kind of hash we're going to use when we build the key here. Go ahead. Well, actually, I guess I can't. I guess I can't copy paste that in, huh? Can I? So we can just do SSH-agent, right? That's what we're doing here. SSH-keygen-t RSA. See if I can remember that successfully. So, why are you trying to highlight? SSH-keygen flag T RSA. And I believe that OpenSSH should have been installed here. So you see, we have now generated a public-private RSA key pair. For now, I'm just going to press enter here. Now, if you wanted to password protect, your key, you would enter a password here. I'll get, at some point we could talk about why you would or would not do this. As long as you are the only one using your computer and you don't share your computer's password with other people, it looks like the session crashed. So you want to send me another code?
Yeah, the network is unstable. It's still sharing from here.
What'd you say?
It's still sharing from here. Do you want me to?
No, I'm saying that the Chrome Remote Desktop connection got cut.
Yeah, that's what I'm saying. It's still active here. Let me set it up again.
Oh, well, I just want to see if we were successful in creating your key.
Okay.
Just let me know.
Okay. It's in chat now.
Okay. And go ahead and try connecting again. Okay, and let's go back to Git Bash here. Okay, we're still on this. Would you like to enter a file? If we just press enter, it will default to the SSH directory here. Enter passphrase. If we don't enter anything, we won't have a passphrase. And so we're just going to not do one for now. And so look, we created a public key and a private key here. Now if we cd, so remember it said it put these things in this directory here, right? So remember cd stands for change directory. We're going to go ahead and we're going to go ahead and cd into that directory. And then let's see what's in this directory. So you see how we have an ID_RSA and ID_RSA.pub. So RSA is the form of key encryption here. So we have an RSA key here. And so the pub is the one that you're going to put on GitHub, and the ID_RSA, that's the private one that you want to keep on your computer. So the ID_RSA is basically, this is called your private key. This is like your ID card. You don't want to lose this. You do not want to give this to others because it's your form of authentication. It says, here's who I am. And so you need to guard this one. The public one is basically like what you need to tell the card reader, hey, this is how you recognize me, right? So this pairs with your private key, but itself is not enough to identify you, right? It's just what needs to match from your actual ID, right? So the public key, that's the one that you give providers like GitHub or Bitbucket or even other servers. So for example, the server that I host our forum on, I use an SSH key to get into that server as well. So it identifies me there. I put my public key there. So public key, I mean, you probably really don't want to go around broadcasting. I mean, although you see, I've actually recorded it in this video and I'm not that worried about it because, it's not my private key. The private key is the one you need to keep private. So now you have these files here, right? Okay, so now on your computer, if you remember, we're inside. So we go here from anywhere on your computer. We're going to cd into your home directory. That's the squiggle, and then .ssh. And that right here, this is where your SSH keys are. So this is the pair of keys that we're going to use to set up that idea analogous to the card, the ID card and the ID card reader that's going to identify you when you use your version control. So now we're going to open up Sourcetree for you. So now we're going to give Sourcetree your private key. We're going to say this is where the private key lives. So Sourcetree actually won't own it. It's going to stay on your computer, right? But we're going to tell it where it lives so that when it tries to connect to a remote Git repository, it will know what key to use. For people who are watching this who don't have Git Bash installed, one of the reasons why it's so great to install Git like this and have a Git Bash with the OpenSSH utility is because it's a very normal utility on Linux systems. And so it's well used and supported, basically. Windows systems also have something called PuTTY, P-U-T-T-Y. Oops. Did I open the installer, not the application?
It's supposed to be installed.
Huh. No, okay, now it's going to actually prompt us. So I'm actually going to say no, so that you know where it is when we open the application. Well, actually, no, that's mine. Let's go on your computer. Okay, here's where we are, right?
Okay.
So if you go to Tools here, and then you go to Options. So Tools, Options. Then we're going to go down here, and you see right here it says SSH Client PuTTY/Plink. This is what I was just talking about. This is a different form of key authentication. We want to choose OpenSSH. That's where we identified our key, right? And this path right here, does this look familiar?
Yeah.
Right? If we go look in your terminal, right, and we're in the SSH folder right here, SSH/ID_RSA, that's where your private key is. If we come here and we look in Sourcetree, this is your home folder, user / your name, that's your home folder, /SSH/ID_RSA, this is your private key. And this is exactly what we want. This is the SSH key that we want Sourcetree to use to identify you. Okay, and then we're just going to press OK. So now it has your ID card. It's like you're wearing it in a lanyard around your neck, and you can go ahead and scan it when you need to get in places. Okay, that's the analogy for us to keep in our head there. And the important thing is that you're not using PuTTY, you're not using this other form, you're using OpenSSH. So if you generate your key pair with git bash like we did here with that SSH-keygen utility, then you are using OpenSSH. That's the kind of SSH key you have, and so that's the selection you need to pick. Okay, so we're going to press OK, and now this knows who you are. Okay, so now you're set up in Sourcetree to use your private key. So next thing we need to do, boy, you have a lot of tabs open here, is we're going to go ahead and go to github.com. Now, to my recollection, you do have an account here. So I'm going to pause the recording for a second and let you get logged in and stuff, and then we're going to go ahead and add your public key to your account here. So I'll pause the recording and we'll pick up momentarily once you're logged in. Okay, so having logged in now, we are going to go ahead and go to your settings here. You know, we just did this for me, so we're going to go ahead and set up the same thing for you here. So we go down here to the thing that's got the key icon for SSH keys. And then what we're going to go ahead and do is we're actually going to add a key here. So we don't care about these. I actually don't even know what a GPG key is, but we care about SSH keys here. So this is what we want to do. We want to add an SSH key. And what we're going to do is we're going to title this, what do you want to call this? This is probably your laptop, right?
Yeah.
So something like that, right? We want to name it so that we know what this thing is, what this represents. So right now we need to go in and we need to open this key. So we're going to go into your file system here. So if you remember, we were looking at that on the command line, but we want to actually go find you here. So if we go look at this PC, we go on your C drive, we can go to users here because C users Audijima, this is your home folder here. You see this folder right here, SSH, this is where we just were, right? Okay. Yeah. And now we decided that we want the public file. So maybe it's not obvious to you. This one's the public file because it thinks it's a Microsoft pub file. So if we go and we click properties on this, just to make sure, because we don't want to give them your private key, right? We want to give them your public one. Security details. Yeah. See, this one's called ID_RSA.pub. This is the one we want. This is your public key, right? Okay. So just convincing us that that is in fact the public key. Well, we can go ahead and we can just edit this with Notepad or whatever. We want to copy whatever this is. No, not that. I don't know why it thinks it's that. Open with something normal, not publisher, like Notepad or VS Code. Choose another app. Windows being silly here. More apps. How about Notepad? Notepad's fine. We don't really care. We just want some way for us to see this file here. Okay, so this is what we want, right? See, it starts with SSH-RSA and it's got all this gibberish here. But this is the thing that's going to identify you. You see your email right there too.
Yes.
Or not your email, your like who you are, right? This is your identity. Okay, so we're going to go ahead and we're going to copy this. Then we're going to go back to Git here. And if you see here, you see the key, it wants your key. And so we titled this Audie's personal laptop. This is the SSH key on your laptop that we just generated. And you see how the text here, this is what we're supposed to put in here. It says it's supposed to begin with one of these things, right? You don't have to worry about what all these are other protocols, right? Remember when we were talking about the password hashing, you heard of SHA, right? Like SHA.
Yes.
And we knew that there were different versions of it, like, 256-bit or whatever. Well, same deal, RSA, different encryption algorithm here, but we have your key. And so it says it's supposed to begin with something like SSH-RSA, right? So we paste in here, oh, look, what does yours begin with? SSH-RSA. That means we did the right thing, right? We're copying the right thing. So we grab that, we put your public key here, and we're going to save your public key on your GitHub account. Okay, and so now you have a key here. This is called your personal laptop, and it's a 256-bit encrypted public key that you're going to use here. Okay, so for now we think we have things set up. So you have a private key on your computer, a public key here. You just signed up with the security office. In our analogy, that's what you just did. You said, here's who I am, here's my identification information. They sit there, they look at your passport, your driver's license, whatever else. They say, okay, you are who you say you are, we believe you. You're good to go now. Now, next time you scan your ID card, it'll let you in. That's what we just did. That's what we just set up here. Does that process make sense? Why we're doing it makes sense?
Yes, yes.
All right. So next thing we're going to do here. So we just did this process through step 4, right? So we used git bash, we cd'd into our home directory, we used the keygen utility of OpenSSH to generate a new public-private key pair. We added the private key to Sourcetree. We added the public key to GitHub, which is our version control provider. And the next thing we need to do is we need to test it, make sure it's working. So we'll get to step 4, that's what we just did. And then we're going to talk about setting up a remote repository to test with. Okay. So there's actually 2 different ways to connect a remote version control repository. That's like the ledger at the bank. There's 2 different ways to basically set up a local one and connect it to a remote one to get the 2 talking to each other. So you can either start locally, so you start with a personal ledger and then eventually you get one at the bank, or you can start with a remote repo, clone it down, and only then begin working. So you start with the bank one, and then you make a copy of that personally. In my opinion, the latter approach, the second one, so starting with the shared repository is easier. I think it's easier to wrap your head around. I think it's easier in practice. It's the approach that I almost always do when I make a new repository. So that's the one that we're going to go through together. I did include the set of commands to run to do it the other way. I just think it's more complicated. So I'm just being opinionated here. This is my opinion. Maybe other people have reasons why you'd want to do it the other way. One example is if you're starting a project and you don't have internet access, well, you can't connect to the shared one, then you have to do it locally. But in general, in our internet connected age, I think it's easier to start with the shared one, right? I think it makes sense too, right? Since we're always going to have the shared one, it kind of makes sense to have that first, right? This is our final, this is the set in stone record that we're going to deal with. So it kind of makes sense to have that be the starting point, right? So like I said, just do keep in mind that I'm being opinionated here. We're going to go through my opinionated way, the way I think it's proper to do this, but you can actually go in the other direction too. So I'll skip ahead here. Doing it the other way, this is what you have to run, something like this. I'm doing it from the command line just because, well, actually, I'm not even sure if you can do it from Sourcetree the other way. Maybe you can. Like maybe you have to connect. I've never done it. I'm lazy and just know how to do it my preferred way and don't actually bother with the other way. But if you're interested, I've done this before. You can, on the command line, you can set it up like this. So what we're going to do here, though, is we're going to do it going forward the way that I like doing it, which is where you start with a remote repository and you clone it down, and then only then do you begin working in your project. So what we're going to do then for you is on your GitHub account, we're going to go ahead and we're just going to make a new repository here. Okay, so this is you. This is your GitHub profile here. And right now we had an example repository here where we were going to do this before. I think we decided not to do that website, but you do have a repository. So what we're going to do actually is we're going to add another repository. Right? We're just going to call this, oh, what do we want to call it? I don't know, like a test repository, maybe. So you want to pick a name here and create a new repository.
I think the test repository you said is good enough.
Okay, so we'll call it test repo. How about that? Test-repo. That's going to be the name of our new repository. Repository test out version. Okay, so this is what we're going to do. We're going to make it public. I'll talk about this later. Basically, if you have a private repository, not everyone can see it, right? It's not public on the internet. If it's public, anyone can see it. right? For open source stuff, of course, it's going to be public, right? For this, it doesn't really matter that much, but we can go ahead and just leave it public. So we can add a README file here, and the README file is just going to be where you could document things in your project, right? Let's say that you wanted to make this an open source project, then we might pick a license. You remember how I said there's different licenses, right? We talked about the Apache license and MIT, right? Those are two of the more permissive ones. And then there's also the GPL, which is copy left, right? It forces, if you use any code with this license, it forces your entire project to be entirely open source, right? So let's say we wanted to license your project in the MIT license. We'll just include the legalese. It'll include the boilerplate and say, this is how you can use this code. So let's say if we wanted to do this, okay? So we're going to go ahead and do all this, and then you just press the create repository button. This is why I like doing it this way. It's nice, pretty, you have a graphical user interface, and then, hey, look, you actually already made a commit. See, this thing is called initial commit. GitHub did this for you, okay? So we have a README file here, and then the README file right now, all it contains is the header, and it contains the description, right? So test repo repository to test out version control, okay? That's all it contains. And then we also have the license file, and if you ever want to go read one of these licenses, well, here's what it says, you know. It's actually not very long, right? MIT license, only a couple paragraphs, right? Permission is hereby granted free of charge to any person obtaining a copy of this software, blah, 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 to deal without restriction. It says you can do whatever you want with it, basically. So this is the new repository we've made here, okay? So what we want to do now is we want to get this. This is in the bank. You just created a new account ledger at the bank, and you said, okay, now if the IRS comes and does me, I don't have anything in it, but now they know where to find it, right? We've created the official record. And like I said, this is the order I much prefer. Make the repository first, then clone it down locally. So after this, we're going to go ahead and we want to get this. So you see these options here, HTTPS, SSH, and the GitHub command line. We're going to pick SSH. Why? Because we set up SSH keys, right? Remember that?
Yeah.
This is how we want to be dealing with this. If you do HTTPS, it's going to ask you for password authentication, right? So you'd have to enter your GitHub username and password every time you did something. But we just set up our ID cards and our ID card scanner, right? That is our analogy. That's how SSH keys work. So we want to deal with things in SSH. So we're going to go ahead, and how I got here was I clicked the code button here, and then I picked SSH as the option. Now I'm going to go click this. This means copy it to your clipboard. This is the web address. So SSH is a protocol. So this is us requesting an SSH connection to GitHub for the repository that we've created here. Okay.
Yes.
So now we're going to go to Sourcetree here, and we're going to say clone. Remember what cloning means?
Yes. We're making a copy of the main repository of the bank's copy of the ledger.
Right. We're making a copy of the bank's copy of the ledger. That's right. So we're going to click clone, and then it wants a URL. Well, what did we just do? We just copied one, right? And destination path. Do you want to put this? Do you want to put this in your documents folder? Is that fine?
Yes. Yes.
Okay. It doesn't really matter that much, right?
Yeah.
So it's got everything set up now. We're going to call the folder name test-repo because that's what we called the Git repository. Okay. And all we had to do after we set up the repository on GitHub was we had to go copy this to get where your Git repository lives on GitHub. And then we went into Sourcetree and we just pressed clone, this nice big button up here. It says clone. If you wanted to add a local repository rather than a remote one, you'd click add with the folder icon here. But here we're going to download it. We're going to clone it from the bank, right? And then we get to pick the folder. If you wanted to stick it in a different folder, you could stick it in a different folder. It doesn't really matter that much. But documents, not a bad place to keep your repositories. So we're going to take it from here. This is the address we copied in. We're going to build our repository here, okay, with this. And then we're going to press clone. And this is going to copy the bank's ledger down onto our local computer. And you see how it's spinning, it's spinning, it's spinning, right?
Yeah.
Okay, it's working. And boom, now we're on the main branch. So the repository has actually been cloned. Now, if you want to see something cool, I think GitHub will actually track whether or not your key has been used. And so we can go back to our settings. Remember, we set up our key card to scan, right? And previously it said we had no uses of it, right? I'm not actually sure if this would have required authentication. I think since it's a public repository, it might not. When we push to it, oh no, see, it actually did get used here. See,
Yes.
it says we used it. We used it because we accessed your Git repository via SSH, right?
Mm-hmm.
So we actually scanned your ID card and the bank said, okay, you're good. So you scanned the ID card when you came in to grab a copy of the ledger, by analogy, right? So we're going to go to your profile, and then from your profile, we can get back to your repositories. Well, okay, let's go to your profile like this, not that one, the one that the public sees. Okay, so you have a test repo here, right? Okay, so now we're going to go look at the repository. This is what we have, but now you have it locally as well. And so if you want, we can actually go in VS Code here. Let's go in and add a Python file. Now, we're not going to set up the virtual environment and stuff. You certainly can later, but for now, we're just going to go ahead and we're going to open this repository. So we're going to open a folder and we saved it in documents, right?
Yes.
Documents. And inside documents, we have this thing called test repo. We're going to click in test repo and we're going to click select folder. Okay. And it's loading. Yeah, we trust the authors. Okay, see here we have our license file and our markdown file. Let's go ahead and add a file. Let's just add a hello world.py file. Hello world.py. Okay. So this is something that we have now added locally, right? So this is a local repository. This is our ledger that we're carrying around as a person. And so let's just here print hello world. Okay, this is a very simple Python application, right? This is a valid Python program. It's just a single line. So now we've added a file, right? And so in our local ledger, we've added a file called hello world.py. Okay, and now inside of Sourcetree, we come to Sourcetree here. We're on the main branch, right? Now, you remember what I said about how we don't want to be making changes to the main branch directly. We don't want to edit the history directly, right? Remember? So what we're going to do is we're actually going to make a branch here, right? And we're going to call add hello world application. That is going to be the name of our branch, okay? Our branch is going to be called add hello world application. So we're going to create the branch here. Okay, so now we're on this branch. You see how this one's bold and this one's not bold? That's how you know which branch you're on in Sourcetree. Okay, so we're on this branch. We're going to go file status here. You see we have a file that's unstaged. Do you remember what it means for a file to be unstaged?
That something like it's not yet, it's not ready to be pushed. Right?
So it's not actually pushing, it's committing. So the difference between staged and unstaged files is any files that are staged will be added to your next commit. And any files that are unstaged won't be added to your next commit, right? But here we want to make a commit, right? So what we've done is we've made a branch, or we've called our branch add hello world application, right? So now we've added a file. So now we've just staged this file, which means next time we commit, this file will be there. Okay. So on our add hello world application branch, we're going to say create new Python file. So this is called a commit message. I actually realized I didn't talk about this when I talked about commits. You always want to give your commits a name, right? And you do that in the commit message. And the commit message should be short, should be descriptive. You shouldn't have fluff in here. It should tell you what the changes you are doing represent, right? So for us, you can see the diff here. We just added a file that has one line in it that's print hello world, right? Okay, so and you see this box down here. We're going to check this for now. It means that when we commit, we're also going to push. So actually, let me do it separately for now. But I actually typically keep this box checked because most of the time, if you make a change, as long as you're connected to the internet, you want to share this with your teammates as soon as possible. Because if you're properly working on a development branch, like you always should be, right? Like I said, you want to be working on a branch other than your main branch, because you want to save that one for when you have history. Now, like I said, if you're a solo dev on a single project, you're the only person pushing to it, you don't have to work on development branches, because then you have to merge the branches in, but it's still better practice. So I'm actually do as I say, not as I do, because I haven't done this very much. But you should do it. I'm just sloppy because I know well enough how version control works and stuff, but it's probably a good habit to get into anyway. So we're going to create a commit message here called create new Python file. And then we're going to commit first, and then we're going to push. Okay. So in Sourcetree, once you've committed, we'll be on the history here. So you see, we've got this little tree here. This represents, the history of our version control here. Now, once you have multiple branches in your repository, this thing gets really complicated. But for now, we have the initial commit. If you look in the initial commit, this is what the first commit was. And we did this when we created the repository on GitHub. So we had the README and we had the license file, right? And now we just added a Python file here in this one, our hello world Python file. Okay, so now we're on the add hello world application branch, right? Not the main branch, but this new branch. And now we have a commit on this branch, but only locally, right? So the next step for us is we want to share this. We want to share this new thing that we're doing. We want to share it with anyone else who might want to see. And to do that, we need to push. Okay. So see this button up here? It's called push, right? So we have a commit on this branch in our local ledger that we haven't pushed to the shared ledger yet. To push it to the shared ledger, we're just going to press push. It's going to ask us, which things do you want to push? We say we want to push this one. Okay, so we're going to push that one. Okay, so no errors, no problems there. Now this is cool, okay? So you want to come here and look at your initial application. This is before we refresh the page. So right now it says that the state of your application is at the initial commit, right? But now if we refresh this page, right, because we pushed to it, you see how we have this branch here? So this is the main branch, right? But we created that branch locally. Now we push that local branch. So over here, this is the local branch. And on that local branch, you see how it says this branch is one commit ahead of main. And now on this branch, we have the license and the README file. That's what we started with, but we added our Python file here too, right? That's what we just did. And the commit message is called create new Python file. Remember, we just did that. But the cool thing is, you see how we're accessing this on the website? This means that our branch has now made it into the bank's ledger, right? You following?
Yes.
So we have two branches now. The branch that we just made a new change on, and that branch is one commit ahead of master. So we've done something. We've added a change here. It's on our new branch. That branch is ahead of master. So now the last thing that we're going to do before we close off today is we're going to go ahead and we're going to open a pull request. So we added this file here. Let's say, you know what, we're good. We've made the changes we want to do. We've accomplished our objective, which was to add the hello world application. Right, to add the hello world application, actually all we need to do is add a file called hello world.py, right? Now, arguably we could add a launch file and stuff too, but we're just going to keep it simple. Okay, so this is the one thing that we're going to do. So now we're going to go to the pull request tab. Different version control software have things that look different. So we're going to do a new pull request here. And the pull request that we're going to make is going to be that we're going to pull this branch here. We're going to pull this branch into the main branch here. So you see, it's called main here. Also may see older things called master. Doesn't really matter. Both of those are conventional names. So we're gonna pull the add hello world application into main. And so you see, if we do this, it's going to run a check here. It says that we don't have any merge conflicts, and that makes sense, right? Because all we're doing is we're adding a file, and no one else is doing anything on the branch since we last branched off of main. So it kind of makes sense that we don't have conflicts. So we're going to go ahead and we're going to create the pull request. And once we create the pull request, you'll be able to see all the changes. I guess we're just going to give it a title. You should almost always write a description of your pull request, like what it's doing and stuff, but we're just being lazy because we want to get this. Okay. So it's checking it merge. It says that you have no conflicts on this branch. right? That means that there's no problems. There's nothing that's going to mess you up. Someone else using your resources, you touching the same file as someone else, right? Okay. And so because it has no conflicts, it says we can merge whenever we want. And so that's what we're going to do. So we've created a separate branch to do our work on so that we can meet our task. We can work on our work item. We can achieve the goals that we have here using as many commits to that branch as we needed. Here, we only needed one commit. If you do something more complicated, you probably want to split the work you do into multiple commits, right? And each commit should be atomic and separable. But here, we only did one commit, and we've created our branch. We pushed our branch so that now the bank has a copy of it in its ledger. And now we're saying, hey, we want to add this to the final history, the thing that's set in stone. So we opened a pull request to do that. So everything makes sense.
Yes.
And now, because we have no conflicts, we can actually just go ahead and we can press merge. And so it's going to ask us, do you want to do this? Yes, we want to do this. So it's actually going to create, I think it's going to create a commit for us here where it's going to say it merged it for us. And so you see over here, now that we've merged this branch, this is why we can say we can delete the branch, right? Because now that we've merged it, we don't really need two copies of the same changes. But before we do that, before we delete the branch, let's go look at the code here. So now we're looking at the main branch again. You see how the branch says main, but look what file is in our main branch now. Hello world.py. Well, you remember locally on your computer, hello world.py is not in the main branch, right? So if we switch to the main branch over here, we just switch branches. And by the way, Git is smart. So we just switch branches. And you remember how we had this folder open in VS Code, right? So now we're on the main branch. Look, there's no file there, right? See how it says it's deleted, right? So if we try to open that, it's going to say, well, I mean, it says it's not there. It says it's deleted, right? But now, so you see, it's not in the file tree. But now if we go back to Sourcetree, so this is when we're on main. This is before we've pulled, right? So this is, again, showing you the difference between your local copy of the repository and the bank's one. We haven't pulled on these branches yet. So on the bank's copy of the ledger, the main branch actually already has the hello world.py file, right? Because we just merged the pull request, but you haven't pulled the main branch locally yet. So your local copy of the ledger doesn't know that yet. But so I just switched back. We just saw that on main, we didn't have the hello world.py file, right? But here we switch back to our development branch. And if we go look in VS Code again, suddenly now that file appears, right? And so why I'm showing you this is because when you switch back and forth between branches, it will automatically handle the files for you. So you don't have to try to remember or anything. You just need to switch between the branches here in Sourcetree. Okay. And so now we see that on our remote repository, we see that we've merged the pull request. And you see how, in terms of the commits on this repository, so there was the initial commit, there was the commit here to create the Python file. This commit was actually done on the other branch. But when we merged the branch into the main branch, the commit ended up getting merged too. Now you can do something called a squash merge. I don't want to get too off topic, but a squash merge basically ignores all of the commits on the development branch. And when you merge it into master, acts as if there was only one commit for that entire pull request. Does that make sense?
Yes.
Now, you might do that if you try to keep your history clean. Usually most people don't do that. Most of the time you want to see the individual commits. So most of the time you won't squash merge, but sometimes you might. Okay, so we've decided that on our remote repository, the bank's copy of the ledger, now we actually have our changes because we merged our pull request. So now the next thing that we want to do is we want to come down to, oops, that's not you, that's me. We want to come down to Sourcetree over here. We want to switch to the main branch here because now we want to get the current state of our application. And what we're going to want to do is we're going to want to pull now, okay? Because now we want to get the bank's copy of the ledger. So we're going to pull the main branch from the remote repository. Now that that pull request has been done, now that we've integrated the changes that have been set in stone, and we'll give it a sec to complete here. Our SSH key is making the handshake and letting us get in. And now you see how there's like a little bit, there's a blip on the graph, right? So we branched off from main initially. And when we made a branch called add hello world application, right? And on that branch, we had a single commit. And then after that, we merged the branch back into master. So you see how we had a branch, and then we merged the branch back in. See how this visually represents what we just did? Right?
Yeah.
Okay, and now if we go to VS Code, remember we're on main. In fact, we can actually right click on this. We can click delete. We don't need this branch anymore, right? So we're deleting it from our local copy of the ledger. We can actually also delete it here from the remote copy, right? Because now we're done with this, right? So you see 2 branches here. So now that we're done with the pull request, we actually don't need the old branch anymore because we are going to have, now you can leave it around if you want for history. If you leave all of your branches around though, things will get really cluttered, right? So you see this branch says merged, right? So we could click delete there. I think if we go back to the pull request, it'll probably ask us if we want to delete it now. Closed pull request here. All right, we can go look at the closed pull request. So this is the pull request that we just closed here. Let's see if it has like a, would you like to delete this branch option here? Merged. No. Oh well. Yeah, here we go. Pull request successfully merged and closed. So we closed the pull request. Now we can just click the delete branch button. This will remove it from the remote repository. Okay, so now if we go back to this repository here. Now it used to show 2 branches. This is the bank's copy of the ledger, right? We just merged it into the main branch. So the main history, the thing that's set in stone in the bank's copy of the ledger, we actually just deleted it locally as well. And so now that we've deleted it, when we go back to the repository, it won't show up as a branch anymore. So now, see, we only have 1 branch. Make sense? So last thing we're going to do here is we're going to go verify. We're going to do a sanity check, right? So we're in on our main branch here locally. We've now pulled from our remote repository. We've gotten the updated contents from the bank's copy of the ledger ever since we merged that pull request in the remote repository. Now we have the changes. We pulled down the changes. Now we're on the main branch. And now on the main branch, we want to make sure that in VS Code, we see the Python file. It should exist, right? So I said, remember, VS Code switches to the files based on, it's mine, based on what branch you're on. So we are currently on the main branch, which did not used to have the Python file, but you see the history here. Just convince yourself we have merged the pull request. We go look at it in VS Code. You'll see that we have the Python file now on the main branch, not the branch that we actually added the file on because we merged the branches.
Yeah.
Does that make sense, at least at a high level?
Yeah.
Okay, so that's where we're going to stop today. I know that was a lot of information. This was our first hands-on example to creating a repository on GitHub, to linking the repository locally, cloning it down, adding a change, making a branch, making a pull request, merging the pull request, pulling the changes. All of that stuff is related to things that we talked about last time. And so, if you want an assignment, things that you can practice off of this, you just try this process a couple times, make some changes, commit your changes. You can even make more than one commit to a development branch, open a pull request for your development branch, merge it into the main branch, pull the main branch down. That is the main development cycle that you will be in as a software developer. Over time, you might not do this every day. It depends how big your tasks are. Sometimes you might do this more than one time a day. Sometimes you might work on a separate branch. You might work on the same branch for like a week. It really depends how big your change set is. But this sort of thing that I just showed you in the real world, in production environments, you will actually do this every single day, something along these lines. So I showed you the real thing. We're not cutting corners here. This is what it's actually like.
Okay.
Now, of course, this application that we're doing here, is saving the world, right? Of course, what this is most commonly used for is developing on teams. And so if you have a bigger application, you have a lot more changes happening. You need version control to sort everything out. As we move forward in our programming practice, so I want to spend maybe one more meeting or 2 meetings to make sure that you're comfortable with local development in Python and you're comfortable with version control and pushing and pulling and branches and commits and stuff. Because moving forward in our lessons, I will actually make a Git repository and you're going to connect to that Git repository. And every time I add new exercises for you, you're going to pull those exercises down from the remote repository. And then when you add your attempted solutions to the exercises, you're going to add a file and you're going to push it up to the remote repository, and then I'll pull it down and I can check what you did. And then I'll push up solutions and then you'll pull down the solutions. You track everything I just said? We're going to use version control partially just to have you practice, but also because it's very convenient, right? This is a way for us to deal with the same code base on 2 different computers because we each have our own ledger.
Okay.
All right,
Okay.
so that's where we'll leave things for now. You know, I don't think I'm going to spend too much more time on definitions and stuff in version control. We're going to try to learn by doing a little bit. And so now that we've set all this up, next time we'll work on building a little bit more of an application. You know, in fact, if you like, you let me know what you think of this. We could actually try moving our storefront application that we've been working on into its own repository and setting it up like that. That might be a good exercise for us to try. But that's the high-level overview. We did some code examples today. Now, let me do my outro here. Here's the things we did, right? So we looked at examples of all these things, actual code examples rather than a high-level overview. We talked about SSH keys. We set up an SSH key using OpenSSH and Git Bash. We added your private key to Sourcetree, your public key to GitHub. We made a remote repository on GitHub and then cloned it down, right? I said, this is by far my preferred way because it's super easy. You saw, you just, click the clone, we go here. Okay, this is my view, but you go here, you click clone, and it's that simple, right? Having made the repository on GitHub. But if you don't do that, you would have to do, well, actually, let me go to my slides. You would have to do this other thing here, some process like this. You have to add, you make your local repository, then you have to tell it which ledger from the bank you have to use. That's what this thing does. It says, hey, I want to use this ledger. That's basically what it says. And then you push to it. But this is a little bit more complicated in my opinion. That's why I like doing it this way. So that's what we did today. And next time we'll keep going with version control. Make sure you're comfortable with it. And then moving forward in the future, that's where we'll have all of our exercises, and I'll post solutions to exercises. And that's where we'll do tests as well, all through version control. So that's where we'll cut for today. And that's where we will pick up next time.